Question number 5 of assignment 8 is asking us to find the inverse of matrix A. Now, inverse of matrix A, the symbol is A to the power minus 1 and its formula is 1 by determinant A into the adjoint of the original matrix A. Now, how do we find adjoint? By finding the transpose of the cofactor matrix. So first let me find the minor of A. Now to find the minor matrix of A, what I'm going to do is I'm going to replace each element by its minor. So instead of 24, I'm going to delete the row and column to which 24 belongs. So what I'm left with is 7. I'm going to write this as 7. Instead of 15, I'll have to delete the row and column to which 15 belongs, and so I will get it as 8. Instead of 8, I will write the minor of 8 is 15. Instead of 7, deleting the row and column to which 7 belongs, I am left with the minor is 4. So minor of A in a 3 cross 3 matrix, the minor will be the second order determinant. Okay, so from the minor of the matrix I can get the cofactor. Cofactor of matrix A, and to get the cofactor of matrix A, what I'm going to do is I'm going to assign the appropriate sign to each element. So remember, it is to each element you are going to add the sign minus 1 to the power I plus j, where I is the row number and j is the column number. So when you do that, your signs that are going to come are, I'm writing it in red, sorry, the signs that are going to come are plus, minus, minus, plus. You can confirm that using this formula. So applying these signs to the elements in the minor, I get the cofactor matrix A as positive 7, negative 8, negative 15 and positive 24. Now finally, what is adjoint? Adjoint of matrix A is nothing but the cofactor of matrix A transposed. Some books use dash as the symbol for transpose, some books use the superscript T for transpose. Whichever you are comfortable with, just remain consistent with your symbols. So transpose of the cofactor matrix will give me my adjoint matrix. So that is 7 minus 15 and minus 8 and 24. Right? This is fairly simple and not taking too much time because it's a 2 cross 2 matrix. A 3 cross 2 matrix is slightly more step intensive. Now looking at the formula, A inverse is 1 by determinant of A multiplied with the adjoint A. So what is the determinant of A? The determinant of A is, since it's a 2 cross 2 matrix, the determinant of A is 24 into 7 minus 15 into 8, which is equal to, so that comes up to be 48, which means A inverse is equal to 1 by 48 multiplied by cofactor of adjoint A, which is 7 minus 15 minus 8, 24. You can either leave it like this or use your calculator to actually divide, multiply 1 by 48 with each element and write it in decimal points. Remember, best practices mean that you leave at least 3 decimal places, but yeah, even if you reach to here, I will give you your marks. Now, the second bit of the question is to verify whether A inverse into A is equal to I. So, A inverse into A, that's 1 by 48 into 7 minus 15 minus 8, 24. So that's A inverse into A, and the matrix A is 24, 15, 8 and 7. 8 and 7. So the scalar 1 by 48, I'm keeping it as it is. Remember, matrix multiplication goes like this. Also, since this is a 2 cross 2 matrix and the second one is also a 2 cross 2 matrix, my resultant matrix will also be 2 cross 2. So just bringing a little bit more space here. So that's 7 into 24 minus 15 into 8, 7 into 15 minus 15 into 7 minus 8 into 24 plus 24 into 8, which is again 24 into 15 plus, oh, I'm so sorry, very sorry. Minus 8 into 15 plus 24 into 7. That gives me 1 by 48 into, so this is, that is 48. 7 into 15 and minus 15 into 7 gives me 0. Minus 8 into 24 plus 24 into 8 gives me 0. And this gives me 48. So when I do the scalar multiplication means multiplying 1 by 48 into each element of the matrix, I will get just nothing but the corresponding identity matrix. The end.